Hello, everyone. My name is Sage Pacheco. I am the Marketing and Customer Experience Specialist with WiseConn. Today, we are going to be having Ceres on for the first webinar of our 2022 Integrator Series. We have Matt Ribeiro on behalf of Ceres today. He's an account executive with them, and he's going to give us the overview of Ceres capabilities and how high resolution imagery can benefit your operation as we are moving further and further into an ag tech focused world. We're going to have a short Q&A after the webinar. So if you have any questions, please just drop them in the Q&A box and we will get to them right after the webinar. If there are any issues with screen sharing or sound, please just go ahead and raise the hand or drop your question in the Q&A box throughout the webinar. That would be greatly appreciated. All right, we'll go ahead and get started. So first and foremost, I'm going to talk a little bit about WiseConn and what we specialize in, and then we will go ahead and introduce Matt and then get into the Q&A. So first and foremost, for those of you that don't know, WiseConn is a high-tech irrigation management company. We were founded in 2006 in Chile. We're a Chilean-based company, and we've been in California in our US office since 2015. We are serving over 310,000 acres with over 14,000 nodes or infield hardware units deployed in the field across the world. We work through a dealer-based network, so we have 60 distributors or dealers across the United States. 41 of those are just in California alone. We have distributors across California, Pacific Northwest, and in the Southeast United States. We are currently present in 11 different countries across the world. And we have a fully staffed support team and warehouse in the United States as well as in Chile. So our US office is located in Fresno, California, if you need to contact the support team. And we also specialize in our API integrations, which we will get more into today talking about Ceres, but we have 12 of those integrations currently in place. Again, so what is DropControl? We are an online irrigation management system. We like to refer to DropControl as the remote control of your operation. So as mentioned, DropControl is a reliable irrigation monitoring and control system. We pride ourselves in being the forefront of the automation industry. Automated irrigation is what we specialize in. It's our bread and butter. However, we do have our hand in many other telemetry aspects. Here's a key image in describing how DropControl, which is our product, works in the field. So we have 3 different types of those in-field units, as we mentioned, which what we call nodes. I'll get into those in a little bit. You can see the 3 are listed here, X1, M1, and C1. All of these nodes talk together to each other in the field, and then they receive comments as well as report back to the gateway or the central node in the field. That data or information is then sent to the cloud and saved forever for their users to be able to access and monitor. So growers own 100% of their data. Here is just a brief list of the capabilities that we offer and specialize in. So remote cloud scheduling, so scheduling from your online software, scheduling irrigations, that is. Local control as well, so locally controlling your irrigation systems from the infill nodes themselves. Pump start stop, so starting and stopping a pump. Wireless valve control, so valve control directly from the field. Remote fertigation scheduling, you're able to schedule fertilizer from the DropControl platform itself along with your irrigations. Irrigation monitoring, so flow, pressure, etc. You're able to monitor that on the DropControl platform. Soil moisture monitoring, reservoir well control and monitoring, weather monitoring, acid injection, as well as pH control, plant sensor monitoring, as well on the software system. And of course, what we're talking about today, some Ndvi analysis. We offer fully remote capabilities, as well as the ability to receive notifications from customizable alerts from the field that you can get on your phone, laptop, iPad. Getting into DropControl and what we offer, we are a software and hardware-based company. So starting with hardware, We have our 3 units here. So we have the X1 node. This is our monitoring and control node. We like to call it our flagship node. This has full monitoring and control capabilities all within the same node. Then on the left-hand side, the M1 is our sole monitoring node. So it can monitor soil moisture probes, weather stations, pretty much any sensor you have in the field. It can operate as its own radio unit. So DropControl uses a 900 megahertz frequency that all the nodes talk to each other through. That information then goes to the cloud. So essentially this M1 node could either be a cellular gateway in itself or a radio module for any other gateway. And finally, the C1 node there in the middle. So this is the pump filter station control node. So the C1 can stop and start 5 different pumps and 10 different valves just from this one unit, as well as fertilizer pumps, acid injection. And the C1 actually is now capable of filter flushing remotely from a device or locally from a screen that you can actually just retrofit on any C1 node or purchase a new C1 node with the screen attached. So filter flushing was our latest release. Getting into software. So as mentioned before, you can control and manage everything from a mobile device or computer. If you're scheduling an irrigation, you would do so on your device. It then goes through Amazon Web Services to the WiseConn server. Then that information goes to the gateway in the field, and the commands get sent to the radio nodes within the field. You can also do this through a third-party platform via our open API. So you can schedule your irrigation through another company's platform, and our hardware in the field will execute it. So this is a part of that open API that we really value ourselves on, such as the one that we now have with Ceres. Here's something similar to what you would see if you were viewing your account through DropControl on a desktop. So basically, when we start your new account, a map is created using a KMZ file on Google Earth with the coordinates of your ranch and the blocks within the ranch. So we then can place the location of each node on the map, which is all of those white circles you're seeing there, with all sensors and information that are configured to that specific node. So here's where you're able to see the status of each node, status of each sensor, charging status, signal, as well as based off of parameters that you set for yourself on DropControl. You can see some even color changes on each block showing your soil moisture levels. Next, just something you would see after scheduling on DropControl. So we get operational feedback via sensors that we have in the field. So that top kind of lighter blue horizontal bar that you're seeing was the scheduled irrigation via DropControl. And the darker blue bar just below it is the operational feedback. So it's showing what actually happened. So the date, when it was executed, time, volume in inches, flow, pressure, pretty much any sensor you have configured to your system. That operational feedback is going to show here. Weekly view, so you're able to see any scheduled events in previous weeks and upcoming weeks. Soil moisture monitoring is a telemetry system or unit that we utilize a lot on DropControl. So a lot of growers rely on these soil moisture readings to depend their future irrigations, or maybe to view trends in their irrigations. Also ET, rainfall, you can all track via the soil moisture monitoring platform on DropControl. Via our API, we can connect to pretty much any soil moisture sensor in the field that you currently have, as long as the API on their end is compatible. So you don't have to purchase the soil moisture probes that WiseConn sells. High frequency irrigation is a form of irrigation that a lot of our growers use. So for instance, this grower changed from irrigating once a week to twice a day. So they made more of a pulse irrigation system. They saved 15% of water, as well as average 3,000 pounds per acre, with no irrigator on site, no ponding, and no runoffs of water, as well as 38% production increase on an off year. So just utilizing that remote control system, being able to irrigate much more without having an irrigator on site and pay for labor, they were able to not only save water, but also increase production. Variable rate irrigation is a form that a lot of our growers use. So they were working 2 different blocks and then separate those blocks into 10 different ones. And they, on the left, you can see the different blocks that they were irrigating per node. And then on the right-hand side, you can see based off of the soil types, they were able to create kind of their own blocks to be able to irrigate differently per different soil needs. Per variety irrigation. So this grower has many different varieties of their crop. So they wanted to split off the blocks to be able to irrigate or fertigate differently per variety. So that remote control allowed them to do so. Flow meter readings. So a lot of our growers utilize the irrigation data on DropControl. So flow, pressure, inches applied for not only record keeping, but also just to be able to see firsthand right away what they're putting on in their field. So this chart on DropControl is showing them weekly accumulated volume. So the amount of volume per water that they were putting on in the week, as well as accumulated volume for a specific date. So maybe longer than a week, shorter than a week. And then the green kind of varying line is showing them flow. So they're seeing flow meter readings based off of how much they were putting on. Per valve pressure. So this grower had pressure switches on their valves in the field, and they were able to see that firsthand right away the pressures from the infield valves. Sequential valve control. So this grower wanted to close and open multiple valves kind of at the same time, or maybe like a minute or so after each other. So DropControl allowed them to schedule irrigate or valves to close within 1 minute of each other and then open another sequence of them. Well, and reservoir monitoring is something that a lot of our users utilize, especially here in the Central Valley. They need to know exactly where their well or reservoir levels are at all times. So based off those sensors in a well or reservoir, we can connect those to DropControl so you can see right away or previously where your levels were at. Again, back to our API integrations that we're focusing on today with Ceres specifically. These are all of our API integrations that we currently have. So like I said before, we're able to share information and data to better serve our growers. Maybe their goal was to have everything on one platform, or maybe they just wanted data available on both platforms. Either way, our open API allows us to connect to various companies. All right, so that is all I have for the WiseConn end. I'm now going to introduce Matt from Ceres. He is one of their account executives, so he's going to go in depth on some high resolution imagery that Ceres offers and how that can benefit your operation possibly, or if you were already a Ceres customer, maybe how our new irrigation or integration, with WiseConn and Ceres can better serve you.
Yeah, appreciate everyone who hopped on today. Like Sage mentioned, my name is Matthew Rivera. I'm with Ceres Imaging. I lead our Central Valley team. And yeah, here to talk to you today a little bit about what we do at Ceres, as well as our integration with WiseConn, which we're really excited about. Being able to provide that much more value to the growers that we work with, and a lot of great insights from the field. We're living in a precision farming world. This is this is a time, as we all know, where we need to be accurate with our inputs as cost fluctuations, commodity pricing fluctuations, a lot of things out of our control. We need to be very much in control of those things that we can manage on the day-to-day operations. So as we see, as we get away from things like flood irrigation and bulk nitrogen applications to precision applications, we're already doing that in field. So taking on these challenges that we're seeing every day and moving forward. Different times call for different measures. We've been using and implementing different tech innovations in agriculture for quite some time now. drip irrigation back in the 90s, GPS use in farm equipment. I remember that was something I thought was crazy to think about as a junior high kid, thinking tractors just driving themselves. And now we see how kind of pedestrian that is in the grand scheme. As we move on into imagery and in-field sensors, being able to access that data remotely, and now to the integration and scalability. So taking in all those bits of information and putting them in one location and using them all together to drive implementation. And our journey at Ceres started with irrigation use detection. That was an area that we thought we could help growers up and down the state and worldwide. Figuring out how well the water that you were intending to get out in the field is getting out to all parts of the field. Really tough to do distribution uniformity checks every irrigation, but with something like what we offer at Ceres, we're able to get that scalability with each and every one of our flights. And a lot of our innovation too at Ceres, I do want to kind of tip my cap to the growers we work with. A lot of our new product developments have come from grower feedback, growers telling us the problems that they're having, things they'd like to see, and us taking that on and understanding where they're coming from and trying to develop things to help them in field, to help them become more sustainable and more profitable. So to really thrive, not just survive. And so right here, we have an example of our flagship product. So that image on the left, that is an example of our water stress imagery. So what we're doing is measuring temperature variability off the canopy of the tree, the vine, the plant. So the blue is going to be the coolest area of the field, the most freely transpiring. And we get to those reds and yellows, there's going to be a little bit higher temperature, higher stressors. Just to the right of that, we see an example of our Ndvi imagery. So that we're tracking canopy growth and vigor. And in the image we see on the left, so we see that southern about third of the field pretty uniformly unstressed. And we start to see an uptick in stress to the north of the block. Now, that being said, in the Ndvi imagery, we're not seeing much of a drop off there. One of the great aspects of our imagery is its ability to be proactive versus being reactive. So we see this image, we fly the field April 13th, April 14th, grower has the imagery back. We can get back into the field April 14th, April 15th. So 24-hour, 36-hour turnaround time on the imagery. So we're able to get back in field and ground truth that issue very quickly. So we get out in the field, we see that there's some issues with valves in field. We make some adjustments there. We go on to that May 6th flight. A few weeks later, we see that uniformity has greatly improved with no issue and no effect on our canopy growth and vigor. So again, one of our main goals and objectives is to highlight growers to these acute irrigation issues, get out, make an adjustment in field before there's any sort of impact on yield or the overall health of the tree, vine, plant, what have you. This was part of our annual irrigation report that we put out every year around the return on investment of issue detection. So it's kind of our hypothetical 1,000-acre grower, over 300,000 acres of growers that we worked with this past season, looking at about 30 issues per season across the growing season, with about a 15-acre average issue size. So looking at those 30 issues affecting about 15 acres per issue. The estimated impact on yield. So for every % of cumulative stress that we detect over baseline in field, we're looking at about a 0.5% reduction in yield. So generally speaking, if we have an area of the field that's 20% more stressed on average than the baseline of the field, we're looking at potentially about a 10% loss in yield at the end of the season. With the estimated $8,000 per acre revenue, that's about $166,000 estimated revenue loss per season if you were to do nothing about these issues, if these go undetected throughout the growing season. So when you add all these issues up over the growing season, they turn out to be quite a large number in impact on the grower. So talking a little bit about that cumulative stress and quantifying our uniformity, the block on the left, you can see that darker purple, those are going to be our repetitively cooler areas in the field. And where we move to that yellow in the northwest corner, those are going to be our warmer, more stress on average areas of the field. So that's a low uniformity field, a poor performing block from our perspective. Versus the field on the right, where we see much more of that uniform color throughout the growing season. This is actually a metric that we provide throughout the growing season. There's always going to be a little bit of variability in the water stress imagery as we move throughout the season due to timing, ambient temperature, irrigation variability. But what we're actually able to do is quantify over the season, average that stress out to highlight the poorer performing areas of the field. And on the right-hand side, we actually have an example of our transpiration uniformity scorecard that we provide at the end of the growing season. So our growers will take this, prioritize where they need to get out and spend a little bit of time in the off season. And we can take a look at the higher performing fields, but really highlight and dig in on the poor performing blocks, go out, make some changes in the off season, different amenities, maybe an adjustment of irrigation systems and types, maybe implementing something like a WiseConn to better address poor performing areas, and set us up for a strong following season. A new offering that we have this year is around our custom water demand maps. So we're actually able to get a custom KC value per each individual block, and we can actually break this down into individual irrigation blocks. This really helped our growers this season and last season, as we were kind of ramping up with this, to figure out where they can allocate more or less water based on what the actual demand is. So instead of taking a real broad approach to irrigation, we're actually getting a real kind of micro approach. So taking those individual blocks that we can maybe pull water back from, push a little bit more to the blocks that need it. If you have something like a WiseConn drip control system, you can actually do that on the fly. So just giving, again, talked about the precision ag, the being mindful of our inputs. This is one of the great ways our growers have been able to do that, really prioritize and highlight where the water is most needed, where they can confidently pull back, saving money on applied water, electrical costs, all those different areas. We can track those changes on a few different levels. You can see on the image on the left, that is an example of our imagery, our plant level insights imagery. So we're actually getting a water stress score per individual tree or vine that you have in the field. So you're not going to go and treat individual trees, but what that does, it allows us to quantify impacts of changes. So, we carry out a flight, we get those metrics back. It says that we're, for example, 25% of our trees are in that highest stress category. We go ahead, we make a change, we flush our lines, we tweak a valve, we break up our run times. We have a flight to come on the backs of that, and we can actually measure the efficacy of that change. Did we progress or regress? If we made that change, we see a movement from highly stressed to unstressed, we're on the right road, let's continue down that path. Or we actually saw a regression. We need to pivot our practices and try something else. Then we can also, on the right-hand side, see that we can actually break those up into larger management zones, to irrigation level zones. And I'll get into a little bit more on that here in a few, but just a lot of ways we can look at the imagery. So being able to take those like micro level quantifications and turn them into macro level changes and implementations. So Ceres Imaging and WiseConn integration, this is something that we were really excited about over at Ceres. Really excited to provide this to our growers. So many times I've sat in meetings and growers tell me, hey, it'd be great if you guys could take this WiseConn stuff that I'm using already and with you guys and kind of put them in one place. We see a lot of benefits of this. Like I said, the reducing time switching back and forth between apps. It's a headache to flip through different tabs on your computer, different apps on your phone, trying to compare things, jumping back and forth. So having these all in one location, whether it's the WiseConn platform or the Ceres Imaging platform, provides a ton of value and just reduction of headache for our growers. Contextualizing and in-field point data within the variability of your operation. So really, quantifying the areas in the field in which we have different in-field sensors, seeing how representative of the field is that particular area. So helping growers out with probe locations and setups, quantifying that information, how representative is this soil type in a particular block. A lot of different ways we can take a look at the information that WiseConn provides with what Ceres provides and make some solid decisions based on that. Also syncing irrigation zone stress data with irrigation automation. So kind of similar to what I was talking about with the KC maps before, and I'll be touching on that here in a few, but being able to take that zone level stress information and make some real-time adjustments using some of the WiseConn tools to quickly implement change based on the feedback you're getting from the imagery. So seeing the probe data in the context of tree level variability, really it's just saying, how representative is the area in which my probe is located? This is a great location of the probe, not in the completely most unstressed area in the field, not in that high stress field, kind of in that sweet spot that is really representative. So when we see that probe data says that we have solid saturation and moisture content in the soil, we can say that that's representative of the field as a whole and be confident in the information that it's giving us. So seeing the water stress at the irrigation zone levels, this is talking a little bit about before, and actually one of my colleagues, John Bourne, was speaking with a grower in the Valley today, and one of the things that he thought was awesome about what we could provide with the imagery now on top of the WiseConn tools that he's using. He can take a look at an image like we see here and say, hey, okay, I have these 3 blocks that are, great uniformity, unstressed, but I have a couple blocks that are underperforming relative to those. So, maybe he can literally tweak the irrigation run times from his phone to address those areas. And then we have a flight in a week or 2 of that change. We could see, again, measure the efficacy from a block level of that change. Are we progressing or are we regressing? Just, again, painting the picture with the tools that both Ceres and WiseConn provides to our grower to help implement change on a real macro level. These are the types of changes where we see those big ROI achievements with our growers when they're able to take 40, 50, 100-acre blocks and improve those throughout the growing season. Again, kind of a real-time example of getting ahead of issues before they impact yield. So, we can see that WiseConn probe. It's in a great spot in field. We can actually click on that probe, and it'll pop up your irrigation soil moisture graph here. We can see the date of the flight, so it's a couple days post irrigation. One thing that's great about soil moisture probes is, obviously they measure the moisture content in the soil, but they're not everywhere. And so what the grower was able to notice in this image is that we have a couple of these blocks that are in that red and yellow, were actually some blockage in the emitters. So they're actually able to get out in field, 24 hours after the flight was conducted, flush those lines, and then we have a flight in a couple weeks again to measure that change. But this is 4 days before the next irrigation, so they're actually able to get out before the next irrigation cycle and make and implement changes. And that's, again, what we're really aiming to do: get out in front of these acute irrigation issues, make some changes before they're affecting our yield, before they're affecting crop health, and implement those quickly, effectively, and then move on to the next issue that will undoubtedly pick up throughout the growing season. I appreciate the time today. Thank you, Sage, for having us on and allowing me to speak today. And look forward to some question and answers here.
Of course. Thank you for joining us. I'll go ahead and check the Q&A box, see if we have anything yet. There's both mine and Matt's contact information, just so you guys have it. Does Ceres cover Ventura County?
We do have some capabilities in Ventura County right now. Yeah, feel free to reach out and figure out where exactly you are. We're covering most of California. We've definitely done some work in Ventura in the past, but yeah, just give me a call, figure out where exactly you are, what you're working with, and we can see if we can't spin you up some imagery.
Awesome. All right. We have another one. So does a Ceres account or customer get all forms of imagery? So like chlorophyll, infrared, NDVI, etc., or is it just one form that is best for that specific operation?
Yeah, so we find a lot of value in having all pieces of the information we provide. So yes, with every flight, you would receive water stress, NDVI, infrared, our core thermal, so an unfiltered thermal image, as well as a chlorophyll. So we provide all those bits of information because there's different things that each piece will tell you about. Sometimes we're not picking up an issue, maybe with the water stress or the NDVI, but we do see a drop off in chloroplast density from our chlorophyll imagery. So that's a great opportunity to go out and do some tissue sampling. So looking at all bits of the information really help our growers optimize the operation and address what needs to be addressed versus potentially looking over an important piece of information just because it's maybe not thought of as super important at the time. So yes, we have about 6 layers we provide, as well as the cumulative thermal stress that we update throughout the growing season with each and every flight.
Great. Kind of piggybacking off that, we have another question. Which layer does Ceres think can work best with automation? Water stress?
Yeah, definitely. I think water stress, again, that's trying to be preemptive with things. That water stress can tell us a lot about what's happening in field before we necessarily see something in the NDVI. So that water stress, again, measuring temperature variability. So we see that uptick in the water stress, but don't necessarily see an issue with the NDVI that tells us, hey, this is an acute irrigation issue. And then that can allow the use with the WiseConn tools to implement a change. So understanding if that's a specific valve in field or a zone block level issue, then we can go ahead and make some adjustments on the fly from the mobile device and implement a change if we need to get water on something as soon as we get an imagery back. Growers with the WiseConn tools are able to flip water over to a block that needs it right then, and again, mitigate any damage long-term crop health, as well as mitigate any sort of loss on yield.
Great. Do you report KC based off of NDVI? If you do you have a specific equation for each crop?
Yes, it is based on NDVI, and yes, it is crop specific. So based on some of the empirical data that we have for each individual crop type. It's why we only at current offer it on a few crops, almonds, pistachios, wine grapes, and citrus, because we put the back end work into validating the existing data around KC values for those crops. I wish I could get into deeper on that, but that's a little bit more of a question for our science team. But for whoever answered or asked that, feel free to reach out to me and we can dig in more with someone from our science team. But yes, it is crop specific based on historical data around KC values for crop specific.
Perfect. We have another one. These are very in-depth. How do you separate soil variations from suspected clogging problems?
That's where it gets a little that's where the ground truthing aspect really comes into play. So the imagery can tell us a lot. Linear patterns, things like that, right angles don't happen in nature. So those are very obvious irrigation infrastructure related issues, set variation, valves, so forth. When we get into some of the less defined patterns, that's where it does require a level of ground truthing. So getting out in the field, a lot of times we actually provide and have the NRCS soil maps for California, where we can actually see if there's a macro soil variation. Sometimes growers have site-specific soil maps that we can actually overlay in the imagery, so we know right away, hey, this is a soil variability. If you can rule out the soil variability, that's when we start doing DU tests in those areas. So catch cans and seeing how well our flow is in those specific areas. So there's a level of ground truthing. We can't absolutely unequivocally say a soil variation, differentiate between soil variation and emitter clogging. That does, still got to farm, still got to get out there. But again, that's going to help you target those specific areas and really save a lot of time in checking those particular areas versus finding them once they become a larger issue.
Great. All right. We only have one more. When is this going to be implemented into DropControl? So as far as the Ceres information being available on the DropControl imagery analysis tab, this is expected to be done in August. We are still working internally on having the Ceres imagery used as a data source on DropControl itself. But as Matt showed, they are able to see WiseConn sensors on their maps. And some of our data as far as soil moisture data goes. So it looks like on the Ceres end, they're pretty off to the races as far as implementation goes. On DropControl, this is still being worked on, just fine tuning things to make sure it's released fully and properly. So we're planning on August as far as DropControl goes. Any other questions, comments? All right. Well, if not, I want to thank everyone and thank you, Matt, for joining us today. I think this is all great information that our customers really wanted to hear. It was pre-recorded or recorded while we were rolling, so this will be posted on both platforms, Ceres and WiseConn, for you to be able to watch later, or if anyone missed it, feel free to send it out. But Matt, if you don't have anything else, thank you everyone very much for joining us.
No, thank you, Sage. Appreciate you and the WiseConn team for having us on, and I look forward to some great grower conversations after this webinar.
Awesome. Thank you.